Excellent. Thank you for coming out tonight. My name is Pat Hawks. I am a software engineer at a startup in West Des Moines called Coviance. We help credit unions automate the lending process. If somebody's applying for a home equity loan, it's generally because they need the money and they want to get that money fast. And so helping the credit unions get the money to the borrowers as quickly and efficiently as possible. And we help to automate and speed up that lending process. In addition to a software engineer, I'm also a private pilot. And I remember back to my 5th or 6th lesson as I was starting to get a little bit more familiar with the controls of the airplane, and my instructor was starting to get comfortable with my abilities. We were just starting the lesson. We had checked out the plane, everything was good to go. We turned it on. We were gonna go from the tarmac down to the end of the runway. My instructor was looking down at his lapboard, filling out some paperwork. I started moving, and I hit another airplane with my airplane. This is generally to be avoided. And as the fiberglass of our wing was scraping against the aluminum of the other airplane's wing, it was immediately clear to both my instructor and myself that this was a catastrophic situation, and we knew exactly what had gone wrong. Fortunately, since this airplane collision took place on the ground, there were no injuries. There was a mountain of paperwork that needed to be filed with the FAA. But unlike airplane collisions, sometimes in software development, when something goes wrong, it's not immediately clear where the problem is. Sometimes what we think is the problem isn't actually the root problem, and drilling down can take some time. I remember just a couple of months ago at work, we had a problem where when a lender invites a borrower to start their lending process, the borrower is supposed to get an email notification where they can create their account and start uploading their documents. And we got a report that these email notifications were not going out automatically. Fortunately, we have a wonderful technology called Ryan, who is able to manually send out these email notifications. Unfortunately, being the mortal that he is, Ryan needs terrible things like lunch and sleeping at night. So this was not a long-term solution to our problem. So we needed to figure out how to quickly get our emails to be automated again. The problem is that this part of the code that sends out these emails was written 5 years ago by people that are no longer at the company, and until 2 months ago had been working fine, so we had no reason to think about this code. So nobody on my team was familiar with it at all. We looked at the code a little bit, but couldn't immediately figure out what the problem might be. Additionally, there was no log information at all coming from this code, so the code wasn't helping us to do our jobs. So after a little bit of time digging in fruitlessly to figure out what the problem might be, we put everything on pause, and my team went through the code and meticulously added log statements wherever anything was happening. Anytime the code was making a decision, we would log the outcome of that decision. Anytime it was retrieving some information from the database, we would log what that information was. Any assumptions that we had about what might be happening, we would put a log statement in for that. We deployed this code to production, knowing full well that nothing that we had done would fix the problem. We were only adding visibility to what the program was doing. This quickly allowed us to draw up on our whiteboard a flow chart of how the program was acting, and we were able to figure out what the problem was and get that solved so that poor Ryan could sleep at night. How much better our situation would have been if 5 years ago the people would have added log messages for us. And then this has given my team a new rededication to making sure that we're adding log statements to the code that we're writing today, so that 5 years from now, when somebody gets a call at 11 o'clock at night, we can have as much context as is possible to debug effectively. So that's what I'd like to talk about tonight. I have a sample toy application that we can look at. This is a simple API where customers can create orders and we can retrieve orders. It does have a terrible problem where every time an order is created, it draws a random number between 1 and 10, and if the number comes out wrong, then we have a problem contacting our payment processor. So that will give us some logs that we can look at. If we run this code, if we run the code properly, then I'm able to hit my post endpoint, and I've created an order. I can hit my get endpoint, and I can get an order. And the code that we're looking at is a Flask application written in Python. Very simple, just kind of a minimum example to get us talking about this. And we can see immediately that there are no log statements of any kind in this code. And so trying to figure out what it might be doing would be challenging. But this is not such a complicated problem. Interaction between software engineer and computer is one of the first things that we approach as we get our introduction to programming. For many of us, our very first program was print hello world. And with this print statement, now we have a dialogue between human and machine. We have given it instructions, and it is giving us output that reflects its running state. And so we can imagine how if I started to put some print statements in here, I could say that we have called post order, and I don't need to type all of this manually because I've done it ahead of time. And we just have some simple print statements that we've received an order from the customer. We're going to check the inventory for the items, calculate a total. And so when I run this version of the code, I need to stop the other version first. Now I can hit my post endpoint. I can create some orders. I can hit the get endpoint and get some orders. But if I try to create too many orders, the random number generator is not on my side. Uh-oh, there was a problem contacting the payment provider. And so we can see in this case that we have a print statement that the payment was declined for Jane. This gives us some hooks that we can go in and start looking at what may have gone wrong. So with absolutely no tricks, no outside dependencies, using only the print statement that we're all familiar with, we are now able to have infinitely more visibility into what the program is doing. But we can do better than that. We can imagine a scenario where we get a report that there was a problem contacting the payment provider last Wednesday, and if I were to look at this to try to figure out what happened last Wednesday, that would be tricky because all I have is a payment declined for Jane. And this is where Python has tools built in that will help us out. Python comes out of the box with a logging module that allows us to do the equivalent of print statements, but optimized for debuggability. And so I have an example of that where I am pulling in the Python logging module with a basic config. I'm creating a logger called orders, and I have the equivalent of my print statements, although I've replaced it instead of print with logger.info when I'm just getting information about the current state of the program, or when we have a problem contacting our payment provider, we're using logger.error. That's the only changes that we've made from the print statement. But when we run this version of the code, we have to stop the previous version first. Now when I'm creating my orders and getting some orders, I can see more structured information. I can see WorkZug is posting some messages. WorkZug is the server that's sitting underneath Flask, helping my Python application respond to the HTTP requests. But now, when I see that we have 2 items in stock, I can see that's coming from the orders inventory logger. I can see that the payment was accepted. We've got some order numbers. And if we just hit the post endpoint enough so that something breaks, uh-oh, there was a problem contacting the payment provider. We should see that that is an error. We could easily search for error in the log messages and quickly drill down to when something has gone wrong. So again, this is a substantial incremental improvement over just using the print statement alone, but we can do better than this. So a little bit of configuration can go a long way with the Python logger. Again, all of this is built into Python. If you're running Python in production, you can use any of this in production. No need to get approval from a compliance team. Python loggers are hierarchical based on the name. So previously, we saw that we had an order.payments logger. The order.payments logger inherits everything from the order logger, and the order logger inherits all of its attributes from the root logger, and that allows us to tune the logger to help us out. So we saw some log messages previously from WorkZug. Well, I didn't write WorkZug. I trust that it's going to do its job, so I'm going to configure the WorkZug logger to only emit warnings. I don't need to see that it started up successfully or read its configuration. None of that is going to help me solve any of my problems. But the payment seems to be a little bit flaky in our code base, and so we're going to set the logging there to be debug. So we will get extra log messages from the orders.payments logger. In other parts of the code base where we have debug log messages, we'll filter those out for now. Nobody's particularly interested in them, only from orders.payment. So this is just a few lines of Python code that allow us to tune our logger to our specific needs. If instead of doing this in Python, we would prefer to do this in JSON or YAML, instead of using the basic config or dict config, or no, rather than basic config, we can use the dict config, and we can import our logging configuration from YAML. And then if we want, we wouldn't have to have that as part of our source control, and so we could tune our loggers on the fly without getting approval to deploy a new version of the application. Also, that helps to separate it a little bit depending on concerns. You could have a different logger running on your local machine versus in development or in production, just depending on what those needs are. But just with that little bit of config, one more thing I wanted to highlight here. When we were printing all of our messages, we were using f strings, which builds the entire string of the log message and then prints it out. But now that we're starting to tune the logger to not put out debug messages in some parts of the code, it would be a little bit wasteful to create those log messages if we're just going to throw them away without outputting them. And so the built-in logger allows us to use this a little bit older percent string building format so that we can say received order from %s for %s, and then it's going to turn the customer and items into strings and put that into the log message. The nice thing here is, it doesn't make too much difference if it's just a number or a small string, but say if customer were a big dictionary where it would be a little bit more computationally expensive to turn that into a string, if we're not going to output that log message anyway, it doesn't bother to format that for us, which saves us some compute time. So we've changed the configuration. We've changed from f strings to using the more logger-friendly format of strings. And we can start that, and of course I'll have to stop the other one, but I've lost the console, so I have to click that anyway. Okay, and so now we'll create some orders. Oh, there's one that failed. And now I see that all of the log messages are coming from my code. I'm no longer getting messages from WorkZug telling me that it's operating normally. I trust that it's doing its job. Also, I've got a little bit of a different logging format here. That's something that I configure. This is a format that I find a little bit more readable. And I can see that the errors are happening. So we can see how we can tune the logger to our specific needs. We can imagine that if we had more than one user creating orders at a time, this would be more helpful than just print statements, but still there's not quite enough information here for me to see, was this order created for Jane or was that created for Bob? I still don't know. I could go and add more information to all of my log messages, but that gets a bit repetitive, and it's possible that I might forget to add that information to the crucial log message that would unlock my understanding to be able to debug. And so this is where the concept of structured logging comes in, that we can add more structure to the log messages so that we can get more context from each message. Before we get into struct log, before we introduce another dependency, I did want to touch on LogGuru. LogGuru is another third-party logging library for Python. It attempts to be kind of a friendlier alternative to Python's built-in logging library. Some people like that it has a little bit nicer syntax. And so if you've been pretty happy with the inbuilt Python logging and you would just like your logs to look a little bit prettier, then LogGuru might be exactly what you need. It's very easy to use out of the box. Not a lot of configuration is necessary. If you're interested in something a little bit more powerful, I and my team have had wonderful success using struct log. Again, this is not built into Python. It is a third-party library that you'll have to use. It's open source. It's very well maintained. Many people use it and rely on it in production. It's not just somebody's hobby project. But when we're using struct log, we will import struct log instead of Python's logger, and we'll set up our loggers with structlog.getlogger instead of logging.getlogger. But otherwise, that's about all we have to do, and now we're using struct logger, and we can start to benefit from it. So what can we do once we start using struct log? Struct log allows us to add additional fields to our log messages. So now, instead of log messages just being a string that we have to read together like prose in a book, logs can start to become a little bit more like events that we are monitoring with data and fields associated to them. And so we could, if we look at some of the code, so when we're calculating a total, instead of having that total as part of the log message string that we output, I'm calling the total a field, which will get added to the log message. Additionally, I've got a little bit of pre-processing that will add some timestamps and some information about the request to the log message, and maybe it would be easier if we just show it rather than talk about it. Okay, so this is the struct log version of the application. We've got color now, which is awesome. And if we create some orders, and we'll go until we get an exception, which is always a fun Poisson game. Oh, there we go. Okay, so now we see that all of the infos are green. I can quickly scan down and see the red text where something has gone wrong. It's pretty easy for my eye to scan the events. that I can see that, oh, this event was payment failed, and then over here we can see information about the payment failure. So this is pretty easy for me to scan. Even better than that, we can imagine that it wouldn't take a regex guru to be able to filter down to, only show me some errors, or maybe I'm only interested in customer Jane because she's the one that reported the problem, so show me all of customer Jane's log messages. But if we want the logs to be parsable by a machine, struct log actually gives us an even better tool than this. These are more structured but still text, but struct log allows us to output each log message as JSON, which we can then use more sophisticated tools to parse more easily. So we'll run that version of the application. And oh, we created an order and had one blow up immediately. So now each log message is its own JSON blob. We could use a simple tool like JQ to parse through these and show me, only the log messages where customer is Jane, or only the log messages where level is error, and then we can drill down to the problem more quickly. So once the log messages become machine readable, we can start to use tools other than our human eyes to filter down to only what we're interested in, which helps to highlight the problem even quicker. But again, we can do even better than this, because there are tools that will help to process our structured logs for us, which I have in stage 5, which we need to stop the other version, kick this off, and then I'll show the code and we'll come back to it to see what it's doing. Actually, that's not the interesting part of the code. So for my example 5, I'm emitting the JSON logs, but then rather than just sending them to a text file, rather than using a tool like JQ to process them, I'm using a tool called logd, which is open source, I found online. So I'm piping all of my log messages into logd. And we've got that running. So now when I create some orders, I am not seeing my log messages on the console. They're being piped into another tool where I can see them in this web interface. So now I can see all of my events. I can see the log levels. Uh-oh, here I see that a payment failed. I'm interested in that, so I could say, show me that whole log. Or, nope, absolutely don't clear all logs. I could set up a filter here. Nope, don't. Okay, no, I apologize. Over here is where I can see just the error message. And now I know that there was a problem with Jane's order. It was this request. I could then filter down to this request ID and see all of the logs that happened while trying to process that. And logd is a nice tool that I can run locally if I'm developing the application on my own machine. In production, we use AWS CloudWatch, which is like this, but far more sophisticated, more bells and whistles. There are other tools available. You can use Elasticsearch and Kibana to look at your log messages, and very quickly drill down to exactly the log messages that you're interested in to see what might be happening with the system. With AI agents, we wouldn't want to give Claude some 200 megabyte log file from last Thursday and please tell me what's happening, but we can quickly filter down to only what we're interested in, and that pre-processing step makes life a lot easier for the AI agent, less context that it needs to keep to be able to figure out what's happening. Another nice thing that we can do is when we've got the structured logging like this, we could say that actually email address is sensitive. I don't want my email address included when the log messages go to logd. I only want email addresses to be included when I'm logging to the file system. Or maybe we've got two different log stores. One is protected by a password, another is more readily available for any firefighters. So we could be more selective about which fields go to which place. StructLog also has facilities for masking, and I think I've got an example of that. Or perhaps I don't. But if we had credit card number in play, say, then we could easily replace that with asterisks so that that's not available in the log messages. That's sensitive. Somebody would have to either log into a different log store or access that directly from the database. But the information that we need is still readily available in the log messages for anybody to see. So these are my code examples. In conclusion, I hope I've demonstrated that if we want to bring better logging into our Python application, this is not something that requires a full application rewrite. We don't need to pause all feature work for 2 months while we go and add logs. This is something that can be done incrementally. No matter where we are today, there are small steps that we could take tomorrow morning at the office to improve our logging situation. Python offers, out of the box, the logging module, which is a tremendous improvement over just the print statement. But if we're willing to use a third-party dependency like StructLog, like LogGuru, we can do even better than that. And we can use tools that can aggregate our logs and help us quickly filter and search to drill into any problems that we might be investigating. And with that, I'd be very happy to take any questions, or if anybody had an anecdote to share about a time when logging saved their butt, I think we could all benefit. Yes?
For the built-in logging module, So my question is, for the built-in logging module, is there a minimum Python version that comes with?
Ooh, that's a fantastic question, and I don't know off the top of my head.
I'm going to guess 3, but is it? It was there. So the basic stuff he showed would be there even in a, some people have to deal with legacy Python, right? So, just curious if you got to go in. That's more likely what you're going to be fixing than the new stuff, right?
Oh, absolutely.
Right? It's something in really old, so that's why I was curious. Thank you.
Thank you. Yes?
I was just thinking, if you did have to add or update an old legacy Python application, could you hack something together to get JSON logs working with the built-in Python just by like JSON stringifying a log message or something? Hack something together, kind of.
Sure. When I have done that before, that didn't live inside the Python application, but instead we had a layer that would read the Python logs, parse out anything that might be relevant, and then pipe those into our log store so that we could still get
like a file beat or something
exactly
like that.
a file beat. Yeah.
Okay.
I was just wondering, have you integrated your structured logging with your APM? Do you have alerts set up on error rates and things like that?
That's a fantastic question. We're starting to do more with that, starting to kind of take some baby steps into observability. I can tell you that we have some emails that get sent to a distribution list anytime there's an error in production. And previously, those emails gave the very minimum that somebody would need to start investigating. Basically, we would have to search for that log in our log store and go from there. But since we've switched to structured logging, now those emails contain at the very top the order number that was affected, the customer that was affected, the file, which helps us to more quickly figure out what might be happening. But yeah, I think monitoring could be a full talk in its own right.
Thank you. Yeah, I saw your last code snippet had like the context bars example, which is like my favorite feature probably. Curious if you or your team has any experience with open telemetry and distributed tracing, things like that, and how you think about, if you do, how you think about when to log versus trace, things like that.
Do you want to speak to that, Stephen?
Yeah, so we do have hotel traces. We go to X-ray with them. The one thing that we have had on more recent applications than our legacy stuff was log correlation. So I think they work well together. I think having a good dashboard as an entry point to troubleshooting is like desired, and then having traces as context as well as logs. Because with traces we get things like the database query that was ran, but I think log correlation, which CloudWatch handles actually really well, as long as you have an X-ray correlation ID, kind of unlocks all of that. So it's kind of both. And yeah, struct log being the first step to just injecting the trace ID into your logs, and then you open the trace in X-ray, and magically all of your log statements are right there, which is nice.
So for anybody that's not familiar, from my limited understanding, once we start to add correlation IDs and trace IDs to our logs, we're able to follow not just the request in this application, but we can see that request across all of our microservices, across the database. When one service calls another, it will pass that correlation ID along with it, and then I can just look for that ID in my log store and see any database queries that happened, as it hopped from one service to another, anything that was required in fulfilling that request. Yeah, great insight. Thank you for bringing that up. Uh-oh.
Have you flown since you fucked up the plane?
Yes. It was, that was not a good day. I did not fly anymore on that day. I think 2 days later I was back in the cockpit and flying again, and it didn't prevent me eventually getting my license. Yeah. Thank you. All right, well, thank you so much. It was a pleasure speaking.
All right, thank you everybody for coming. Thank you so much for your presentation. It was awesome. Feel free to help yourselves. I think there's still plenty of pizza left, drinks. Stick around and chat for as long as you want.
Thank you much.
Thanks.